This is a tutorial on graphing functions. The first function that we're going to graph is y is equal to 2x plus 4. And we're given several domain points, -3, -1, 1, and 3. And to graph this, we're first going to plug each one of these domain points in for x, and then we're going to solve for our range values or our y values. So let's do that. We'll start with the first one, -3. Our equation is y is equal to 2x plus 4. And we're going to plug in -3 for x. So y is equal to 2 times -3 plus 4. So this is -6 plus 4. So our y is equal to -2. So the first point that we're going to plot is -3, -2. Remember, -3 is our domain or our x value, and -2 is our y or our range value, because that's what we solve for when we plug -3 in. So now let's do the next one, -1. So y is equal to 2 times -1 plus 4. So this is -2 plus 4. So our y is equal to 2. So the next point that we're going to plot is -1 and 2. Now let's do +1. Y is equal to 2 times 1 plus 4. So our y is equal to 6. So our third point is going to be 1, 6. And then lastly, we'll plug in 3 for x. So y is equal to 2 times 3 plus 4. So our y is equal to 10. So our final point will be 3, 10. So let's plot these points on our axes here. We'll start with the first one, -3, -2. So we go to -3 on our x-axis, which is right about there, and -2 on our y, which is here. And where these meet is our first point. So let's do the next one, -1 and 2. -1 on the x is right about here, and 2 on the y is here. So our next point is right there. Now let's do 1 and 6. 1 is here on the x, and 6 is up here on the y. So our next point is here. And then our final point, 3, 10. Go to 3 on the x and 10 on the y, which is right about there. So that's our graph for y is equal to 2x plus 4. The next function that we're going to graph is 1/2 y minus 3/2 is equal to 1/2 x. And again, we're given domain points of -2, 0, 2, and 4. But before we plug these in for x, let's simplify this equation so it's a little bit easier to do our math. So if we have 1/2 y minus 3/2 is equal to 1/2 x. I'm going to move this 3/2 to the other side, so we're going to add 3/2 to both sides. So we end up with 1/2 y is equal to 1/2 x plus 3/2. And then to get the y by itself, we're going to multiply both sides by 2. And we'll end up with y is equal to x plus 3. So now that we have our simplified equation, let's plug in our domain points for x and solve for y. So we'll start with the first one, negative 2. Y is equal to negative 2 goes in for x plus 3. So y is equal to 1. So our first point will be negative 2 and 1. Now let's plug in the 0. So y is equal to 0 plus 3. So y is equal to 3. And our second point will be 0, 3. Now let's plug in the positive 2. So y is equal to 2 plus 3. So y is equal to 5. So our third point will be 2 and 5. And then lastly, we'll plug in the 4 for x. So y is equal to 4 plus 3. So our y is equal to 7. And our last point is 4, 7. So let's plug in these points and graph them on our axes. So the first one, negative 2, 1. Go to negative 2 on the x-axis and positive 1 on the y. So our first point is there. Our next point, 0, 3. 0 is at the center of the x-axis. And 3 is about here on the y. So that's our next point. Our third point, 2, 5. Go to 2 on the x and 5 on the y. So our next point is here. And then lastly, 4 and 7. 4 on the x, 7 on the y. And our final point is right there. So that's the graph of y is equal to x plus 3. The next function that we're going to graph is 2y is equal to 8 minus 6x. Again, let's simplify this and get y by itself. So we have 2y is equal to 8 minus 6x. And let's divide both sides by 2. And we'll get y is equal to 4 minus 3x. Now in this problem we're not given a domain. So our domain consists of all real numbers, or any x value on this x-axis. We're still going to pick points and plot them to see what this graph looks like. And since it contains all real numbers as our domain, we can choose any point we wish. Let's pick points that are easy to solve for though. So let's choose negative 2, 0, 2, and 4. And let's plug these in for x and solve for y. So we'll start with the first one, negative 2. So we get y is equal to 4 minus 3 times negative 2. So we get y is equal to 4 plus 6. So y is equal to 10. So our first point will be negative 2 and 10. Now let's plug in the 0. So y is equal to 4 minus 3 times 0. And our y is equal to 4. So our second point is 0, 4. Now we'll plug in the 2. Y is equal to 4 minus 3 times 2. So our y is equal to negative 2. So our third point will be 2, negative 2. And then lastly, y is equal to 4 minus 3. Plug in the 4 for x. And we get y is equal to, this is negative 12, negative 8. So our last point will be 4, negative 8. So let's plug these points in on our axes. Go to negative 2 for the first one on the x-axis, so negative 2, and then up to 10 on the y. So our first point is about here. The next one is 0, 4. 0 on the x is at the center of the axis, and 4 on the y is right here. The next one, 2, negative 2, 2 on the x-axis, negative 2 on the y, so our next point is here. And then lastly, 4 and negative 8, 4 on the x-axis, negative 8 on the y. So those are the 4 points that we found. But remember, our domain consists of all the numbers on the x-axis. So really we could have picked any point, not just the ones that we did, and they would all fit this equation or fit our domain. So to finish graphing this, now that we have an idea of what this graph looks like, you would draw a line connecting the dots. And this is the graph of 2y is equal to 8 minus 6x. For our last problem in graphing functions, we're given a function y is equal to 4/3 x plus 2, and we're also given the graph of y is equal to 4/3 x plus 2. And then it asks us to find y if x is equal to negative 3, and then find y if x is equal to positive 3. Well, instead of just plugging these numbers in for x, let's see if we can use this graph to solve our problem. Let's start with negative 3. If we go to negative 3 on the x-axis and we travel perpendicular to that axis, or straight down towards our function, when we hit our function, we'll turn and we'll go towards the y-axis. And it looks like for negative 3, our y is about negative 2. Well, let's check this. We'll plug it in. If we have y is equal to 4/3 x plus 2, and we plug in negative 3 for our x, we find that y is indeed equal to negative 2. So that worked. Let's try it for the next one. If we go to 3 on our x-axis and we travel upwards till we hit our function, and then we travel back to the y-axis, we'll see that according to this function or this graph, when x is equal to 3, our y value appears to be equal to 6. So let's plug that in again and check our work. If we have y is equal to 4/3 plus 2, 4/3 x plus 2, and we plug in 3, this does indeed equal 6.